I'm delighted to go first before you guys are too caffeinated. Is to do something that was not necessarily a Plexxi infomercial or anything like that. And actually, I'm not really even going to talk at all about Plexxi. I'm going to talk about the infrastructure implications for software-defined data centers. And I'm sure that many of you are looking at this this title, and your initial reaction is going to be, well, it's all hardware is commoditized, right? In the context of virtualization, in the context of software-defined data centers, and you're mostly right. However, there are some subtleties. There are some, I think, nuances to, observations that you can make around the way that, software-defined compute, as we know, server virtualization, software-defined storage, software-defined networking, what properties do those technology, what are historically technology silos, what properties do they need to have in order to enable all the benefits that we all, of course, certainly everyone in the room here sees, with the in the context of a software-defined data center being a pan IT abstraction of being able to deliver compute capacity. So, instead of using commodity, I'm going to talk about cheap and cheerfulness. If there's anybody, I assume there's Top Gear fans in the room. I certainly am one. But cheap and cheerful. It's the idea that it's economical, it's abundant, it's uniform, like the Reliant Robin there from the 70s and 80s. It also needs to be high performance, because of course we're not going to sacrifice what used to be delivered by IT organizations in terms of architecture and configuration. We of course want all that still in our software-defined infrastructure, and of course we want reliability and resilience, right? We want to have that cheap and cheerful hardware, but we want to have, we no longer want to build high availability. We don't longer want to build explicit redundancy and active backup kind of architectures into our infrastructure to support software-defined data centers. We want it to be sort of a natural property. And what really enables that? Right, and I'll introduce this idea that I think maybe hasn't had these words attached before, but I'm sure is in a lot of your minds, is the idea of workload fluidity. That in many ways, if I have if servers fail in my data center, what does it matter? I have plenty. If the workload that I can apply across that infrastructure is fluid enough, is able to be moved sort of freely and without restriction. It doesn't matter if servers fail. I have plenty. I'll just move it where the servers are still working, right? And that idea of workload fluidity has worked great for server hardware, right? It has worked great because, first of all, one of the key properties, from the first slide, the idea of abundance, is that I can buy lots of compute very cheaply now, right? I can buy very high performance, lots of cores, very high performance CPUs, lots of memory. It's getting cheaper and cheaper and faster. Homage to Moore's law, right? That's working well. But server virtualization has also provided a way to provide portability, provide the means to actually migrate edge policy, if you will, edge compute policy, along with the application demands. So, virtualization gives us that, and the nature of distributed applications also gives us that resilience and capacity. So, clustered computing, clustered database servers, clustered, all of the modern ways that we are deploying applications and functionality today in our systems, unlike what it was, 15 or 20 years ago, back when an application was a lump of software sitting on a server, and then of course we had to have really high availability servers, because if the server crashed, the application crashed with it, right? Now, by distributing that workload over an abundance of servers, we get resilience and capacity. But what about the other silos, the other pillars? What about storage? Does this same, oftentimes I think that a lot of things you read, a lot of pundits, say, well, if this worked for compute, why does, it's going to work the same way for storage, it's going to work the same way for networking. And somewhat true, but there's a subtlety. First of all, of course, abundance, there's always abundance, right? Everything's getting cheaper, better, faster. I can actually buy much more storage now than I used to be able to, bits per dollar. Virtualization provides that same portability of edge policy. But the different thing, sort of the unique property of storage is that when an application is running, I need my data. It's not okay if, like I had that analogy before, if a bunch of my storage subsystems fail, it might not be okay because it may have contained the data I need for my application to run. So what really enables workload fluidity from the standpoint of software-defined storage, if you will, is replication, is the idea that data can be reproduced, moved around, and cached so that wherever my compute is running, it has access to the data it needs. And of course, anyone who's following that space knows that there are a great many companies, startups, and big technology projects building all sorts of storage tiers, flash embedded in servers, flash embedded in at rack level that makes that replication possible. And last but not least, networking. What about networking? What's unique about networking? Well, first of all, abundance. Yes, we're pushing bits faster. We're building bigger networks, and the cost per bit per second is going down and down and down. So that stripes over everything. That enables workload fluidity. Network virtualization, once again, provides that one role, right? Providing edge policy portability. That's also key. But the unique property of software-defined networking is that we need diversity. We need more paths between more endpoints, right? Similarly, actually, occasionally on panels with Andy Bechtolsheim from Arista, and his point is always, well, the network needs to work, and he's got a point, right? Because if our goal is to provide workload fluidity, the network is kind of that fluidized bed that makes that possible. It's what allows me to migrate my servers and it allows me to replicate my storage, right? So if the network breaks, how do I supply fluidity? Well, you supply fluidity providing diversity. You provide lots of links everywhere. And so up there on the right, I show just a simple schematic of a lot of the enthusiasm you hear in the networking space today about leaf spine architectures have the great property that they have lots of diversity, have lots of paths between endpoints so that if individual switches fail or individual links fail, connectivity is preserved. And in fact, connectivity and capacity can be preserved. The thing I show below there is even a more innovative architecture using agile photonics to create even richer sets of capacity diversity that allow that to be, that resilience to be delivered without any reduction in performance. So, workload fluidity is the recipe. It's how we make software-defined data center infrastructure that delivers what I think is the overarching promise. And there's really 4 components. Virtualization overall in all 3 disciplines, workload distribution for compute, diversity, path diversity for networking, and replication in data. And if you can do that, you've built excellent infrastructure for a software-defined data center. And the last point I'll make is that the one final component is the idea that there needs to be, once you have this idea of workload fluidity, you have the underlying infrastructure, there needs to be a way to talk about workloads that is pan-IT, spans silos, and is technology neutral, technology independent. And that workload abstraction allows us to talk about what applications do, what their requirements are from the IT infrastructure that's, like I said, spans these silos, and allows us to talk about these things, make them scalable, make them portable, make everything truly fluid. And that is my last slide. So I have a few minutes for questions. Harry.
Dave, I'm interested in your perspective on the situation where you have multiple different products or domains within the IT data center trying to do the same thing. Let me give you a simple example. You guys talk about applications affinity. I like that concept a lot. VMware has this thing called vMotion, and so I can imagine a case where you have a vCenter controller that says, move those VMs where the unused capacity is. And in fact, you can even imagine an extension that would measure the network.
Sure.
You have an independent controller that's saying, no, we're going to reconfigure the network. How do you deal with the coordination of that going forward?
I don't think anyone is, thinks we have this all, cut and dried and solved. There are, a number of different ways that we, in the fullness of, actually building out these architectures, the feedback systems, the servo mechanisms, the ways we understand what the state and the underlying performance capacity of the underlying infrastructure is, and how that maps to the workload abstractions. The application affinities in Plexxi speak, different workloads and other sorts of controllers and orchestration architectures, right? What I believe the right shape of the solution is really in the framework of co-orchestration of these resources through a set of abstract RESTful APIs, right? That will allow both sort of top-down impression of desires of what when I'm doing an application deployment, what are my requirements of the infrastructure, but also servo to the state of that infrastructure, right? So it's some of it is feedback system stuff, right? That good old-fashioned engineering, but one of the let me put it this way, is that one of, I think, the early foibles, right, it actually, certainly in my field, in networking, was, there were literally decades where we spent a lot of time and people's energy and lives and money trying to build, QoS and servo mechanisms for trying to optimize networks by sort of staring at networks, right? And I think those were always doomed to failure, because there was never a point to stand in that architecture that allowed you to measure the performance of the network with respect to what you were expecting the network to do, not what it was doing, right? So it was sort of trying to build a feedback system without an error signal, right? So by, the role of an abstraction like this, right, not only provides a way for users of software-defined data centers to articulate their requirements, it allows those of us who are engineering those systems to build responsive, productive feedback systems that make them, work and become automated. Hope that answered your question. Sort of long. Anybody else? I'm really taking advantage of the fact that you guys aren't caffeinated yet. Mr. Toad.
So when you talk about workload abstraction, what would that abstraction be? I mean, is that something like, for instance, from a platform as a service type of thing, where where applications are sort of
Yes, it certainly can. Like I said, there are a certain set of ways to know those things directly, because the application architect, the guy that's using those resources, can articulate them sort of from first principles. I'm building a database server tier. I know how many IOPS a second it has to do. I know what the network requirements are. I know what the storage requirements are. I just know, right? And so there's that element of being able to sort of impress that directly from the top down. But as you know, because you heaved the question up, there are also ways to servo that, derive that from the performance of other subsystems and legacy configurations. So, I think one of the things we all are going to confront in our careers over the next few years is basically, how do we get here? How do we get to here from where we are, right? And being able to have a robust set of abstractions, APIs, and functionality that allows us to embrace the old, derive configuration, derive application requirements from that, as well as move the world to this model where they can sort of do it directly from first principles, is a process. It's not going to be without, as Harry noted, it's not going to be without a sort of a gawky adolescent phase that I think we're starting to enter right now in terms of these ideas. But I think it's at the end is we get what we want. We get IT systems that are de-siloed, serve the user's requirements, serve application requirements directly from first principles, and are reliable, resilient, cheap, and cheerful. Yes, sir.
So abstraction kind of started back with grid, right, at a much higher middleware layer, and then the big Web 2.0 companies with file systems, VMware more at the hardware level. Where do you think this is going to converge? I understand the abstraction, but there's just so many different ways to conceptualize that and make it happen.
Yeah, exactly. If I had a crystal ball and could predict how this all pans out in the next 5 years, I'd be a really successful investor, I guess, instead of working one seam in this. It is multidisciplinary. It is has to embrace from the top down, we have to do our work in sort of a language, people understand, the people being our users, right? Is, how do we allow people to articulate their requirements into IT systems that have an abstraction that allows them to talk about their needs as opposed to solutions to their needs, if you will, which is sort of the where we've been, right? Is, you might have these great ideas about your application workload affinities and all these things like that. But historically, step 2 was go talk to your network engineering department, go talk to your storage engineering department, talk to people and have them engineer a solution for you, right? That's the part that we have to capture that, what was a lot of manual engineering design and architecture, and recast that in a form that is automatable, integratable, and pan IT, pan silo. Yes, sir.
So I noticed this is a SDC infrastructure recipe. It seems that we're hearing a lot about the pets and the cattle. The new breed of applications are really needed to take advantage of this.
Oh, true fact. And in fact, this is where the Web 2.0 companies, and they have shown us, sort of the way, right? They have, in a lot of ways, Google and Facebook and such, they have the advantage that, unlike a typical enterprise that might be running, hundreds or thousands of different application instances, they're running a handful, right? At their core, right? So, they have clearly blazed the trail in terms of understanding, with clustered, with MapReduce, with Cassandra, with all those cluster architectures and distribution have shown us how this can work, right? I think what we're all here for is to understand how we take that, those now sort of proven ideas and map them into sort of in a more consumer-friendly way, I guess, where it doesn't require sort of much broader focus, I guess.
Could you repeat the question?
Oh, sorry. The question was, doesn't it require a new sort of style of applications and new application architectures to fully take advantage of this? And the answer is yes, absolutely. Yes, sir.
So one of the aspects of that, really addressing the multi-tenancy action in the data center, and as such, issues related to that would be security, and you see issues around multi-tenancy not big enough to warrant a recipe item, or is it, you see that mostly an infrastructure component coming out of much?
At the abstraction level, what I commonly point out to people is that there are elements of this abstraction. We frequently talk about, I say the gravity pieces of it. It's like I have this group of stuff. I might understand what bisectional bandwidth requirements, what storage capacities, what latency bounds it needs to have to do its job, right? So those are sort of the things that kind of pull things together, right? Just as important are the anti-gravity pieces, the keep things apart parts of the equation as well. So there are elements of supplying multi-tenancy, security requirements, isolation requirements, some of which are regulatory, some of which may be just simply avoiding, fate sharing, kinds of problems, right? That has to be part of the abstraction as well, so that, we need to get to a point where we have sort of a full articulation, both in terms of gravity and anti-gravity, of how we, site, host, configure, and automate those workloads. So, and I didn't get it, obviously, in the time I didn't get into it, but there is a whole field of work in network functions virtualization and security that also overlays on top of all this that is just as important. I'm completely glossing over it, but it's just as important as a big field in its own right. Oh, yep.
I have a question about when you have those forms of abstraction, what do you lose in visibility into the physical infrastructure that you wish you had? So if you're still looking at the network side, issues or whatever,
Yep.
you're so abstracted.
Yeah, the question is, what do we lose if we're abstracting? What do we lose? Okay, the hook's coming out. What do we lose in terms of visibility? Well, hopefully, from the standpoint of the user, nothing, right? Hopefully, all that vanishes into the infrastructure the way he hopes, right? That it's just something he needs to worry about. But it is just as it is essential that, especially as we contemplate supplying, virtualized overlays for network, for storage, in a strict sense, we are actually increasing the complexity of the underlying subsystems, right? We're increasing the complexity of the systems we're managing. So we need ever more robust ways to, diagnose, measure, servo the performance of that infrastructure as well. So that's also something that is not understood well enough, not talked about enough yet. And I think that's it. That's it for my time. Thank you all.
Thank you, David.